Now let's take a look at a paired two-sample t-test. So we're doing hypothesis testing. We've determined that we're measuring the population mean differences. In this problem, we're going to be looking at the weights of men and women before and after the weight loss program. Because we recognize that there is a relationship, this is called a paired t-test. So we go down this node of the decision tree. This decision is very critical. And let me just show you. So why is it wrong in this situation to use an equal variance or an unequal variance or assume independency in this case? Well, the t-test used violates the independence between the samples assumption. The test used takes into account the large variances in the weights before and after. So it looks at the weight differences between the heavy men and women and the heavy men and women before and after. So there really is a significant issue. And so the strong caution here is that we should never use an independent t-test when the samples are paired, or in this case, dependent. The question is, did people lose a significant amount of weight as claimed by the SPA? Well, we're asking really a different question here than we did with the independent sample t-test. We're not looking at the differences as a whole. We're looking at the individual differences, or the weights before and the weights after. We're really measuring, is the mean difference in the weights equal to 0 or not equal to 0? This is fundamentally different. Did they, on average, lose weight, or is that difference something greater than 0? So we want to do the test properly. We need to formulate the null and alternative hypothesis. We state the null and alternative hypothesis as the following. The null hypothesis is that the mean difference, notice the subscript d there, means difference, is equal to 0. So we're assuming that there's no weight change. That's the null. The alternative is that there was weight change. Now we're not at this point going to define whether it's more or less. We're just going to say that it's something other than 0. Maybe they gained weight. That wouldn't be good for the weight loss program. We select the significance level first, then we calculate the t-statistic. The t-statistic in this case is 4.58. We'll calculate that using Excel in just a moment. The p-value is 0.0002. Well, the t-stat is greater than the t-statistic. The p-value is less than alpha. Both of those tell us that we should reject the null. This means that the mean weights before and after the program are significantly different. Now, we don't know at this point whether they lost or gained weight. We just know that they changed weight. So we must check to see if the mean weights after the program are lower than before to answer our original question. So looking at a normal distribution, we would assume that any t-stat within this range of a standard normal distribution, we would retain the null. We'd say, yeah, they either lost weight or they gained weight, but there is not a significant difference in weight. There's too much variation to say that they actually lost weight. Anywhere in this area, we'd say, yes, the difference is significant. The mean weight is actually higher after the program, or we would say there's significant evidence that suggests that they gained weight. If our t-statistic in this case is positive, meaning the before weight is higher than the after weight, then we would say that there's statistical evidence to suggest that they actually lost weight. Let's run this using Excel. So we'll use the same data set that we had before, namely the GYM data, GYM data.xlsx. And we know that this is a paired sample, so we're going back to our data analysis tool pack. We'll use the paired to sample for means. Now this is the same tool that we used when we were doing single sample hypothesis testing. And we'll choose the before weight as the first, the after weight as the second. This is indicating that if we have a positive t-stat, that means they lost weight. If we have a negative t-stat, that means they gained weight. We do have labels. Our alpha is 0.05, and we'll put our output here. So the mean weight of all the individuals, men and women, before was 168.9 pounds. The mean weight after was 159.1 pounds. That's a difference of almost 10 pounds. Well, it doesn't sound like much relative to the total variance, but we're not asking it relative to the total variance. We're asking it, is the mean difference for each observation significantly different than 0? Our t-statistic is 4.58. T-critical is 2.09. P-value is 0.0002, just as I had stated in the text. So in this case, we would say that yes, it appears that there is a statistically significant difference of those individuals participating in this weight loss program. So moving to step 5, we compare, we check the direction, we see that it's positive, so the people have lost a significant amount of weight on average, and we make a business decision. Well, there is a statistically significant difference before and after. The weight reduction program appears to be working, or at least there's evidence to suggest that it's working. No bad report is needed from the Better Business Bureau. Now, a couple of notes here. This test collapses over men and women, so the claim is made without regard to sex. If we wanted to compare the before and after weights for men and women separately, since they may be different, then we could do a separate paired t-test, but we'd have to divide the sample into 10 men and 10 women. A problem occurs because when we cut the sample in half, we're decreasing the degrees of freedom or the power of the test, and this makes both less likely to reject the null. The main point here is that if we are doing the wrong test, the independent t-test, then we can come up with the wrong answer, or no significant weight loss. So it is very critical that we understand the difference between a paired and an independent. Paired meaning that the first observation is dependent on the second observation is dependent on the first observation. Independent meaning that we could scramble the two and it wouldn't make any difference.